Hi friends, in this chapter we'll discuss about the properties of solid fuel. Solid fuel refers to various forms of solid material that can be burned to release energy, providing heat and light through the process of combustion. There are many solid fuels like charcoal, coal, agricultural waste, wood, etc. But the most important being coal, which is widely used in industries. So in this chapter, we will concentrate on the properties of coal. If you like my video, then please like, share and subscribe to my channel and share the video with your friends. Please press the bell icon and select all notifications to receive my latest videos. Let us first discuss about classification of coal. Coal is mainly categorized as anthracite, bituminous and lignite. Coal is further categorized as semi-anthracite, sub-bituminous, and semi-bituminous coal. Now, let us discuss more about coal classification. Anthracite is the oldest coal from geological point of view. Lignite is the youngest coal from geological standpoint. Anthracite is hard coal, whereas lignite is soft coal. Anthracite consists of little volatile matter and little moisture, whereas lignite consists of more volatile matter and more moisture. Lignite also contains low fixed carbon. Fixed carbon refers to the free state of carbon where it is not combined with other elements. When coal is heated, the vaporizable constituents called volatile matter vaporizes. The predominantly used coals in the industry are bituminous and sub-bituminous coals. Now, coming to the gradation of Indian coal, the coal grades are based on calorific value of coal. The table shows the different grades of coal and their calorific values. From the table, we find that A grade coal has highest calorific value and G grade coal has lowest calorific value. Normally, we use D, E and F grade coals in the industry. Now, coming to the properties of coal, the properties of coal can be divided into physical and chemical properties. Some of the physical properties of coal are heating value, density, hardness or grindability, particle size distribution, and degree of oxidation. Some of the chemical properties of coal are grade, rank, or degree of qualification and type of coal. Now, coming to heating value of coal, the heating value of coal differs from coal field to coal field. That means coal from different coal fields will liberate different amount of heat energy. The table shows the heating value or GCV of coal received from different sources. From the table, we find that the GCV of South African coal is more than Indian coal. Now, to know how coal will behave during its combustion, two types of coal analysis are being done. They are ultimate analysis and proximate analysis. Ultimate analysis is the determination of different chemical elements present in coal. In ultimate analysis, various types of elements present in coal like carbon, hydrogen, nitrogen, sulfur, and oxygen etc. are determined. Moreover, moisture and mineral matter content are also determined in ultimate analysis of coal. In proximate analysis, moisture content, ash content, volatile matter, as well as fixed carbon content are measured. Now, for ultimate analysis of coal, skilled chemist is required and a properly equipped laboratory is required. But proximate analysis of coal requires a simple apparatus. The amount of moisture or water content in coal is determined by subtracting the dry weight from the initial weight, and the moisture content is then calculated as the amount of water divided by the dry weight or total weight depending on the reporting method. Now let us discuss about how moisture content of coal is calculated. Coal is crushed to get 200 micron sized coal. Then a sample of this powdered coal is taken in an uncovered crucible and heated in an oven to 108 plus 2 degrees centigrade. Moisture content is calculated by subtracting the final weight of coal sample from initial weight of coal sample. Now coming to measurement of volatile matter, a coal sample is taken. This coal sample is crushed and weighed. This crushed coal sample is then placed on a covered crucible and is heated to 900 plus 15 degrees centigrade. This hot coal sample is then cooled and weighed. The difference between the original weight and the final weight gives us the volatile content of coal. The coal which you get at the end of this process is called coke, which consists of fixed carbon and ash. Now let us discuss how carbon and ash content in coal are measured. The cover of the crucible in the last experiment is removed and heated until all the carbon is burnt. The remnant left behind in the crucible is nothing but incombustible ash. The left out product is weighed. The difference between the weight of the product when the experiment started and when the experiment completed is called fixed carbon. Fixed carbon is obtained by deducting the moisture, volatile matter, and ash content percentage from 100. Let us discuss about proximate analysis of coal in detail. In proximate analysis, the weight of fixed carbon, volatile matter, ash content, and moisture are revealed in percentage. Fixed carbon is mainly responsible for the heat generated during combustion of coal. High volatile matter content of coal facilitates easy ignition of coal. Let us discuss more about proximate analysis of coal. Ash is an important incombustible component of coal which is derived from proximate analysis of coal. Ash content of coal plays a vital role in the design of furnace grate in case of FBSC boilers, in the design of combustion volume of boiler, in the design of pollution control equipments, in the design of ash handling systems of furnace like design of economizer hoppers, design of air filters, in the design of bottomless hoppers, etc. Now let us discuss about proximate analysis of various coals. The table shows various coal parameters present in Indian coal, Indonesian coal, and South African coal. From the table, we can conclude that the moisture content of Indian coal is the least compared to other sources of coal. The ash content is the highest in Indian coal compared to other sources. Volatile matter content is minimum in Indian coal and the fixed carbon content is highest in South African coal. Now let us discuss about the different parameters obtained in proximate analysis of coal. The first and most important being fixed carbon. It is the coal weight minus the weight of moisture, volatile matter and ash. Fixed carbon also includes hydrogen, oxygen, sulfur and nitrogen present in coal. It is an indication of the energy content or heating value of coal, that is, how much heat will be generated during combustion of coal. Now coming to analysis of volatile matter. Volatile matter constitutes methane, hydrocarbons, carbon monoxide, etc. It also consists of incombustible gases like nitrogen, carbon dioxide, etc. So in general, volatile matter is an indication of the gaseous fuels present in coal. The range of volatile matter in coal varies from 20 to 35%. Now coming to other significances of volatile matter, flame length increases when volatile matter increases. Volatile matter facilitates easy ignition of coal It becomes a deciding factor in designing the furnace height and volume. Volatile matter also affects secondary air requirement and its distribution. It also affects secondary oil support. Now, coming to the significance of ash content in coal, the product which is left behind after burning of coal is called ash. It is the incombustible portion which cannot be burnt further. Normally, the ash content of coal varies from 5 to 40%. The ash content depends on the source of coal. Sometimes ash content also goes up to 70%. Higher ash content reduces handling and burning capacity of coal. That means if for the same weight of coal ash content increases, then there will be less fixed carbon available in the coal, which is an indication of the heating value of coal. Handling cost of coal increases as ash content of coal increases. Combustion efficiency and boiler efficiency are also affected due to the increase of ash content in coal. Higher ash content leads to clinkering and slagging. Now coming to clinker formation, clinkers form in coal-fired boilers when the fuel source used to power the boiler is inferior. Poor quality coal contains more water and minerals. These compounds break down when heated to high temperatures and the debris that results clings to the sides or floor of the boiler where ash can cover it. Now what is slagging? Slagging is the formation of molten or partially fused deposits on furnace walls of boiler or convection surfaces exposed to radiant heat. In this context, I would like to discuss about another important terminology, that is fouling. Now, what is fouling? Fouling is defined as the formation of deposit on convection su- heat transfer surfaces such as superheaters and reheaters. Now, coming to the significance of moisture content. The moisture content of coal replaces the combustible matter of coal. Combustible matter generates heat and an indication of the heating value of coal. When the combustible matter is replaced by the moisture content of coal, then the heating value of coal decreases. The moisture content of coal varies from zero point 0.5 to 10%. Moisture content adds the transportation, handling, and storage of coal. Heat loss or enthalpy loss of coal increases due to moisture content. The moisture present in coal absorbs some amount of heat from the combustion of coal and gets converted into steam. This steam also absorbs some amount of heat and gets converted into superheated vapor. This superheated and saturated steam also helps in radiation heat transfer. Now, let us discuss about sulfur content in coal and how it affects coal. The sulfur content in coal varies from zero point 0.5 to 0.8%. Sulfur content affects clinkering and slagging. We have already discussed about clinkering and slagging. Another important property of sulfur results in erosion of air heaters, economizers, and chimneys. Sulfur trioxide, which is one of the products of combustion, reacts with moisture present in coal and forms sulfuric acid. This sulfuric acid, when reaches its dew point, condenses and results in erosion of air heaters, economizers, and chimneys. Higher sulfur content facilitates quick formation of sulfuric acid. Hence, sulfur content in coal limits the flue gas temperature in air heaters. Now, let us discuss about ultimate analysis of coal. In this analysis, we find out the weight percentage of carbon, hydrogen, oxygen, nitrogen, and sulfur present in coal. This analysis is helpful in determining the air quantity requirement for combustion of coal. How much volume of combustion gases or flue gases will be generated and what will be the composition of combustion gases are also decided from ultimate analysis. Flue gas dock design can be done by knowing the volume and composition of combustion gases. Flame temperature can also be determined from the composition of flue gases. Let us go through a typical ultimate analysis of Indian and Indonesian coal. From this analysis, we find that the moisture content of Indian coal is less than Indonesian coal. The mineral matter is more in Indian coal. Carbon content is more in Indonesian coal. Hydrogen, sulfur, and oxygen content are more in Indonesian coal. Nitrogen content is more in Indian coal. Now, coming to the relationship between proximate and ultimate analysis, the equations shown here bears a relationship between different parameters of proximate and ultimate analysis. Now, coming to storage of coal, why at all storage of coal is required? We may place order on the coal supplier for supplying coal. Similarly, other industries also place order on the coal supplier for supplying coal. So the coal supplier, as per his strategy, supplies coal to various industries. The coal supplier may not be in a position to supply coal to us when we require. Moreover, there may be strike or unrest at coal supplier end, which may also disrupt supply of coal. So to overcome uncertainty in availability of coal, storage of coal is required. Moreover, transportation of coal may also be disrupted due to various reasons which may result in non-availability of coal. So to overcome uncertainty in transportation of coal, storage of coal is required. Now coming to the coal storage disadvantages. The disadvantages are the inventory of coal will increase, storage of coal exhausts space, quality of coal degenerates when stored in the storage yard as it absorbs moisture and other impurities present in the atmosphere. So, for a given amount of coal fired in the furnace, moisture content increases, which affects the combustion process. Coal may catch fire when stored in a storage yard. All coals, when exposed to air, undergo natural oxidation of carbon, forming carbon monoxide or carbon dioxide and producing heat. Once there is enough heat, spontaneous combustion occurs. This gives rise to fire hazard in coal storage yard. Now, let us discuss about the losses associated with the storage of coal. The first type of coal, the first type of loss is oxidation loss. This results in heating and self-combustion of coal on open storage yard, which is a direct loss. The second type of loss is wind loss. The fine particles of coal present in the coal yard escapes due to high wind velocity, which is a direct loss. It means corresponding amount of coal is lost from the storage yard. The third type of loss is carpet loss. Carpet loss is the loss of material stored on the unprepared ground. The soil and clay matter mix up with coal and some quantity of coal is lost by this. 1% oxidation of coal has the same effect as 1% ash in coal. Wind loss may be considered as 0.5 to 1% of the total loss. Now, the goal of good coal storage is to minimize carpet loss and to minimize spontaneous combustion loss. Now, how to get rid of carpet loss? The first and foremost being is to prepare a hard ground below the storage yard. In this way, soil and clay will not be mixed with coal, which will reduce the carpet loss. The second method is to prepare standard storage base of concrete and block to overcome carpet loss. Now coming to handling of coal, the generation of fines is reduced as coal handling is minimized. Now, what do you mean by preparation of coal? Coal preparation can be divided into three types, that is sizing of coal, conditioning of coal and blending of coal. Let us discuss about each of them in detail. But before that, let us discuss about what are the problems posed by large size coal. Let us discuss about the problems caused by large size coals. When coal particles are converted into fines by grinding, the surface area of coal particle increases. So each small coal particle can come in contact with oxygen and burn easily. Whereas each and every particle of a bigger size coal does not come in contact with oxygen. So all the particles present in a bigger size coal particle may not burn, which will lead to poor combustion or incomplete combustion of coal. At the same time, the coal particles which are not burnt will be discharged to the atmosphere through chimney. This is called stack loss. The poor combustion or incomplete combustion of coal also leads to increased unburnt. As we know, thermal efficiency is the ratio of enthalpy of steam to the calorific value of coal fired in the boiler. In case of large size coal, for generating the same amount of steam, more amount of coal is to be fired. Hence, thermal efficiency of boiler decreases when bigger size coal particles are fired. The advantages of proper coal size are even burning, better combustion efficiency, and reduced ash losses. The size of coal is reduced by crushing and pulverizing. The size of coal becomes 4 to 6 mm after crushing. Rotary breaker, roll crusher, and hammer mill are used for crushing of coal. Bigger size of coal is screened or filtered before introducing it into crusher so that only pulverized coal is allowed into crusher. This reduces power consumption of crusher. A magnetic separator is introduced before crusher to avoid damage of crusher by iron items. The table shows the size of coal to be used for various firing systems. From this table, we see that bigger size coal is used in natural draft hand firing system. For pulverized fuel fired boiler, the coal size should be 75% below 75 micron. In case of fluidized bed boiler, coal of size below 10 millimeter should be used. Now, let us discuss about conditioning of coal. When coal is conditioned with water, finer coal particles come in contact with moisture and becomes bigger gradually. These bigger coal particles prevent falling through grate bars. The finer coal particles are easily carried away by furnace draft. So when coal particles are converted into bigger coal particles by conditioning of coal, these are not easily carried away by furnace draft. Addition of excess moisture to the coal should be avoided while conditioning of coal. Moisture should be added uniformly to coal. This is done by adding moisture with the help of a falling stream of coal. We cannot add moisture to coal as per our wish. There is a limit of surface moisture against a particular fines percentage. From the table, we see that when fines percentage varies from 10 to 15%, then the limiting value of surface moisture varies from 10 to 15%. Similarly, the surface moisture of 25 to 30% coal fines is limited between 7 to 8%. Now, what is blending of coal? In case of coal blending, excessive coal fine is mixed with lumped coal. It is done to provide a consistent feedstock of fuel for power generation or to meet different requirements such as solving transportation problems, fuel cost, reducing slagging, and SOx emission, etc. Different qualities of coals are being blended in blending. This gives rise to a uniform coal feed to the boiler.